Let us continue now for the second part. Now we can form some rules with our previous discussion. Now we have seen the plane's perpendicular to reference plane. So the first rule in the projection of plane says like this: when the plane is perpendicular to one reference plane, its projection on that plane is a straight line. So this straight line in that is nothing but the edge view. So we can conclude plane perpendicular to reference plane, edge view in that plane. In short, we can remember like this. The second rule: when a plane is parallel to reference plane, when a plane is parallel to reference plane, its position on that plane is the true shape and size. So from this again we can conclude plane parallel to reference plane, true shape; plane perpendicular to reference plane, edge view or straight line. Then third rule: when a plane is perpendicular to one reference plane and inclined to other, its inclination is shown by angle which its projection on the plane to which perpendicular makes means indirectly. It is like this: if the plane, if this plane is inclined to HP, so angle with HP can be seen in VP in adjacent plane. So this particular plane, in this particular plane ABCD is inclined to HP, so angle with HP can be seen in VP. So that is the meaning of this particular rule, third rule. And now traces also indirectly we have seen in the above diagram. So what is the trace of the plane? When the plane is extended, if required or necessary, it will meet or touch the reference plane HP and VP in a straight line. And that particular straight line is known as the trace of the line. So these lines are called as traces. The line in which the planes meet with the HP is called as horizontal trace, that is HT. And the line in which the it meets VP, it is called as vertical trace. What is HTVT? Let us see in short. You see here in this diagram now. Now this plane is perpendicular to VP, no doubt. So if I extend this plane, it is touching or cutting the VP at the point A dash B dash. So this A dash B dash is indirectly the vertical trace because it is cutting the VP when it is extended. And now here for this particular plane, if this plane is now it is inclined to VP, no doubt, but if it is extended this way, so this will cut here. This is the position. So this small ABCD is the position of this plane on the HP. So projection is different and this HT is different. So if required, if necessary, so this ABCD plane I can extend here towards the HP and it is cutting the HP at some line. So this particular line is nothing but the HT here. So this edge view itself is the VT, and if this plane is extended here, so this is nothing but the VT here. Similarly, in other diagram also, here also, so this particular plane, when it is extended in the HP, so this view which we have seen as the edge view, so that edge view is indirectly nothing but the HT because this plane is cutting the HP here. Since this plane is inclined to VP, so if I extend this way, so this and this point is coming here, so that point is somewhere here. Similarly, this D and C point, when you extend, it will come here, so that point is somewhere here. So if this plane is extended here, it will cut the VP also at one line. So this one line is known as the vertical trace. So this is the vertical trace, this is the horizontal trace. So these two traces are there for this plane. There are some rules and regulations of these planes, and that also we'll see one by one. Now let us go for the very important case to start with. So plane parallel to HP and perpendicular to VP. So we'll solve some simple numerical problems, and then with these problems we can get the fundamental clear. Now in this particular case, first is the plane parallel to HP. So equilateral triangle is given of the side 50. So equilateral triangle is ABC. All the three sides are same. Has its VT parallel to and 10 mm above XY. Now VT is given. So naturally vertical trace you can see in the VP. Now this vertical trace is in direct edge view, and that edge view is given parallel to XY line and 25 mm above. So you can take this 25 mm, 25 mm. To start with, what is given? Draw the projection when one of the side is inclined 45 to VP, one of the side of equilateral triangle. So here the one side is taken here as the side AC. So select any point here, draw this line at an angle 45. So on that you select the side is equal to 50 from C to A. From A you cut this arc, from C you cut the arc equal to 50. You can locate the point B. So this plane is given parallel to HP. So naturally in the HP you can see the true shape. You can start with true shape, and this true shape you can project here. Now how to project? So project the A point like this, C point like this, B point like this. But now where to draw this edge view? For that already is given that vertical trace, which is indirectly the edge view in the VP. So location of that is given as 25 mm above reference line. So take this 25, 25 and draw this line. So this is the edge view. So from the rule, we have seen that if the plane is showing the true shape in one plane, namely HP, in the VP it is showing the edge view, and that edge view is parallel to reference line, and that edge view in our case is the vertical trace. That is how we can complete this particular question. Let us see another case. Now in this another case now, the plane is parallel to VP. Now square is given ABCD. So this is 40 mm side. Now another condition is given, has one corner on the HP. So this corner is nothing but the corner D here, no? And 20 mm in front of VP. So this is 20. And now here you can use your knowledge of projection of points. So one corner is 1 point. So 1 point is on the HP and 20 mm in front of VP. So distance from VP you can see in the HP. So this 20 mm is the distance of that corner, that is D. Since this is on the HP, you can see the point D dash here. And since this 20 mm above, in front of VP, so that's why you can see this distance as the 20 here. So that is how the D point is located. With this D point, now you can draw the square. Now what is the another condition given? All the sides of the square are equally inclined to HP. All sides means D dash to A dash, D dash to C dash, C dash to B dash, A dash to B dash, and so on. These are the all sides. Out of that, from D, two sides are there, namely D dash A dash and D dash C dash. So take this angle 45, 45, draw this line. Now for the square, we know that this angle is 90. This angle is 90. So from the end of this C dash, you draw this perpendicular line. This length is equal to this length. You can get the point. Now this one is already available, so you can join this. So if you see, since these two lines are inclined 45, so naturally these two lines are also equal 45 to the reference line. So that is how all the sides of square are equally inclined to HP. So angle with HP you can see in the VP. So while drawing in the VP true shape, you have to take care that. So one corner is on the HP, that is D dash. Draw this line 45, 45. Similarly, this is indirectly coming as 40. If I extend this line here like this, so this angle is coming as 45. If I extend this line, this angle is coming as 45. So all the four sides are equally inclined to HP, and that you can see in the VP here. So draw the true shape first in the VP, that is front view. Then you can project this point here, and this point here. Now already this particular point is located. Why? Because it is given that one corner is on the HP and 20 mm in front of VP. So this 20 mm is already taken here. So this point is available to you. So draw the projection, and from this you draw this line. So this is the edge view, and this edge view in the HP is nothing but the horizontal trace. So true shape in VP, edge view in the HP, parallel to reference line. So this case already is indirectly covered here. Now let us go for next important case now. So in this case now, the plane is inclined to one reference plane and perpendicular to other. Plane is inclined to one reference plane, so it is inclined to HP, and perpendicular to other means perpendicular to VP. So this particular case is there. Now in this particular question, we are supposed to draw the four views. Up till now, in the previous question, only two views we are drawn. So view number one, view number two. So either top view first, then front view, or front view first, then top view. Now in this case, four views you are supposed to draw. In the simple position, first you have to start with true shape. How to start with true shape? So when the plane is inclined to one reference plane, its position may be obtained in the two stages. How two stages? In the initial stage, which we are calling as the simple position, the plane is assumed parallel to that reference plane. Means if the plane is inclined to HP, assume parallel to HP. So by assuming parallel to HP here now, let us see how this question is solved. And now in the second case now, you can make the inclination. Okay, to understand this particular theory, so let us go for this numerical question now directly. See here. Now here regular pentagon is given of 25 mm side. So this pentagon is like this: A, B, C, D, E, and this. Now we have to start with this pentagon in the top view. Why? Why that I will explain. Because a regular pentagon has one side on the ground. Ground means HP in our case. And now this is the side AE. And now this AE side, if it is taken perpendicular to VP here, while drawing the true shape, one side should be taken perpendicular to VP so that for this A and E as A dash E dash you can see the point here, and that A dash E dash point you can maintain in the inclined position because we are interested in the inclined position here. So first you draw the true shape A, B, C, D, E as the true shape with AE perpendicular to this. So this C point will come here as C dash, then D point will come here as a D dash, and the B point will come here to B dash. So this is A dash as well as E dash. This is C dash, and this point is B dash as well as D dash. Now this is again the edge view. So this is the true shape. A, B, C, D, E is the true shape of the pentagon, and A dash, B dash, C dash, D dash, E dash is the edge view. Now this edge view is parallel to the reference line. Now what is given now? The plane is inclined at 45 to HP. Now this particular plane is parallel because it is on the reference line and is parallel to reference line here. But the plane is given as inclined 45 degrees means plane means entirely edge of this plane. Now this edge is already available. And now in the next diagram, in the position number 3, so this A dash and E dash point you can maintain here. And this C dash point you can incline at an angle 45. Same edge length you can measure and take this angle 45. So that is the angle of a plane with HP. An angle with HP you can see in the VP with the edge view. So this is already edge view. So incline this edge view with A dash E dash point on the reference line at angle 45. So this edge view is redrawn here in the position number 3. Now in the final position, this is the inclined position actually. In the final position number 4, take the position from C dash like this, C. So C dash and C is C1, B dash and B is B1, A dash and A is A1. So this point is again E dash, E even, and this itself is again B dash D dash point. So D dash and D is D1. So this is the final shape. So this is the final position of this particular regular pentagon.